Let's continue on our AI journey with building scalable, personalized customer experiences with Amazon Personalize. Introducing myself again, I'm Bernard Leong, Head of AI/ML ASEAN, and my colleague Pedro Paez will take you through how Amazon Personalize work together with a technical demo. For this session, we'll focus on Amazon Personalize, an AI service which enables you to improve customer engagement and conversion by powering real-time personalized product and content recommendations and targeted marketing promotions. Everyone's preferences, tastes, and needs are different, and users expect their interactions to be personalized. Personalization improves discoverability of items in your catalog, especially if you have a long tail of items, example, niche products, a large catalog of videos. Personalization is empirically proven to improve engagement on digital properties. Common metrics to measure are click-through rates, or CTR in short, dwell time on articles, duration of videos, and bounce rate. Personalization is empirically proven to improve conversion, or CVR in short, drive customers to purchase an item, add a credit card for a subscription, because they found content that they like, etc. The above factors lead to an increase in revenue for the business. Early personalization experiences on Amazon.com were driven by the need to improve the discoverability of relevant items in our very large books catalog. The algorithm powering this, a type of item-item collaborative filtering algorithm, has since become the bedrock of personalization, not only on Amazon.com, but for many other retail experiences. Personalization takes many forms across Amazon.com, Prime Video, Kindle, Amazon Music, and continues to get better. From the humble widget showing people who bought this also bought recommendations, we have come a long way to personalize many more customer touchpoints. We walk through some of the examples here. These includes widgets which recommend items based on your cart and recent browsing history, and recommendations from a category that is of high interest to the customer. User experience across other Amazon properties is personalized too. We have generalized our techniques to many different kinds of items. This includes a stack of personalized widgets experience, in Prime Video, playlist recommendations on Amazon Music, and book recommendations on Kindle. While personalization is commonly thought of in context of the display channels, it is also very useful when delivered over email and notification channels. So where are we today in personalization? It continues to get better. Continuous advancement in machine learning research at Amazon focus on personalization, sophisticated deep learning techniques that can understand customers' needs at the right time and within the right context, and machine learning models that are optimized for a variety of use cases. For example, shopping, music, videos, ebooks, etc. Most customers start from a rule-based personalization system. For example, a shoe retailer recommends boots for women visiting from New York in November. These systems make intuitive sense, but get really hard to manage as the number of users increases and number of items in the catalog also increases. It becomes hard to define rules which are specific enough to user segments to offer meaningful personalizations. Broad rules don't really do personalization. Even as the human effort on this increase proportionally with scale, the performance does not keep up. We know this because we have tried this in Amazon. In almost all experiments, machine learning-based personalization does better than human-curated ones. So machine learning does work better, but it's not straightforward to do well either. There are several challenges. First, the recommendation system should respond to the changing intent of the user rather than have pre-computed recommendations. It should handle cold start user or new user and new item scenarios. Cold start user and item handling is easy for a rules-based system, but not straightforward for a machine learning-based system. Next, recommendations should not fall for popularity trap. It is easy to build a naive model which recommends mostly popular items but hard to build which shows relevant recommendation from non-popular items. Unlike some other applications of machine learning, there is no master algorithm to solve all the subproblems in personalization. Personalization is ML 101, but good personalization is hard. We have found that ML experts are needed for building good models. The combination of these challenges means that most customers stick to rules-based personalization or no personalization at all. With Personalize, we aim to get you out of the box solution to foundational use cases for personalization. You can use these capabilities for generating a broad array of personalized user experience. They are personalized recommendations. For example, recommended items for users from a catalog on a landing page. Here is an example of such a recommendation from Prime Video, where we are recommending videos from the Prime catalog. Second, related items. Recommend items similar to a selected item on a detailed page. This is e-commerce workhorse. In the example on screen here, we are recommending rugs based on the particular rug I have selected on Amazon.com. And third, personalized re-ranking. For example, to re-rank a list of items within a category or in response to a query by the user. In the example on the screen here, I'm getting recommendation for audiobooks on Audible within the classics category. Introducing Amazon Personalize is basically using the same machine learning technology perfected at Amazon.com with no machine learning experience required for the developer to implement them. And these are the benefits of using Amazon Personalize. First, it reduces the time it gets with personalization to weeks from typically greater than 6 months period for such projects down to a few days. Second, the technology behind Personalize is well tested for performance and scale. And third, Personalize uses deep learning sequence model, which greatly improve upon the baseline matrix factorization algorithms commonly deployed for recommendation engines. Fourth, Personalize can be used by all developers and does not need machine learning expertise. And five, your models are private to you and only used for generating recommendations for your user. Neither AWS nor Amazon will use your data and models for our own purposes. So with Amazon Personalize, you can deliver high quality recommendations to your customers, adapting to changes for the customer intent in real time, training a recommendation model with a few clicks and with new data, and generating recommendations for almost any product or content. Here are some customer references for Personalize, but I'm going to tell you one that's in ASEAN. Pomelo Fashion is a leading omni-channel brand based in Bangkok, Thailand, with a global customer base. To quote Paulo Almeida, the VP Engineering from Pomelo Fashion, our goal is to be the best omni-channel company in Southeast Asia. We work relentlessly to make that dream a reality by constantly improve the customer experience at all stages throughout the shopping journey, both offline and online. We use Amazon Personalize to deliver a unique shopping experience to many customers across the globe. Amazon Personalize allows us to seamlessly provide this personalization at scale. For Pomelo, Amazon Personalize is not just powerful, but transformational in today's e-commerce world. How does Amazon Personalize work? To do this, I hand over to my colleague, Pedro Paez, our machine learning specialist, solution architect, to take you through the technical details and demo. Pedro, over to you.
Thank you, Bernard. Hi again, my name is Pedro Paez, and I'm a machine learning specialist for AWS. So I'll be walking you through kind of the technical details of Amazon Personalize. We'll be looking under the hood of this specific engine, and we'll talk a little bit about how you can actually start building an end-to-end recommendation engine. So one of the first things we typically look at when we talk about personalization is kind of the evolution of how people kind of think about personalization from kind of their historic beginnings to where they are now. So traditionally, most businesses or marketing teams, when they thought about personalization, they were really thinking about what we call customer segmentation. So trying to define groups of their audience based on kind of taste profiles, and based on kind of that information, creating a rule-based system to define the type of offers and how you were going to engage these particular users. Now, of course, this had a lot of caveats. One of the big problems with this approach is that basically you were painting with a broad brush, with broad strokes, kind of the taste profile of a lot of your customer base. Where we are now with personalization is what we call hyper personalization. So people are now expecting what we call segments of one, right? So instead of looking at broader groups and then trying to define common characteristics, we really are trying to profile each individual customer and trying to create an offer, a customized offer for each of these customers. So as we've come to this concept of hyper-personalization, what we've seen is that a lot of the modern techniques for creating kind of this granular set of recommendations or set of offers is done through, or most effectively through, what we call statistical methods, or typically machine learning models. Why is this? Because, of course, when you're looking at scale, it's really hard to have a rule-based system to define, for every specific customer. Statistical models really help here. Now, up until recently, typically when we talk about recommendations engines, we were thinking about things like matrix factorizations, collaborative filtering. Now, a lot of these traditional methods, while better than rule-based systems, or even more scalable than rule-based systems, they do have their complexity. So the first thing, for example, is that they are complex to build because you're building machine learning models. Second thing is that a lot of these models were typically static in nature, as in they didn't take into account the evolution of customer taste or customer behavior. And finally, typically they are completely based on I would say historical customer interactions. So things like new users and new items were traditionally kind of complex issues for these type of applications to handle. This is what we call the cold start problem. So that's kind of where Personalize tries to solve these things, right? So when we talk a little bit about the dynamic behavior of customers, we know, for example, that when we navigate a specific web application or e-commerce website, yesterday I might have been looking at watches, but today, the moment I start looking at shoes, I'm expecting that the system doesn't get stuck with the idea that because I looked at so many watches yesterday, it should be offering me watches today. What I want the system to know or to understand is that today I'm looking at shoes, and it should be offering shoes now, right? Now, traditional systems, as I said before, they're a bit static, and they were not able to they would look at all the watches they looked yesterday. They saw this as a strong signal for watches, and then today when I start looking at shoes, they would have started offering watches, right? So we need kind of a new system, a new method for embedding that type of the change in how I'm looking at information or at my catalog of items. So that's where kind of Amazon Personalize comes in. Now, Amazon Personalize is basically a service that has been built based on decades of Amazon.com's experience building recommendation engines. It's based on a lot of the same recipes and algorithms that Amazon.com uses for their recommendation engines. It's a fully managed service in the sense where you really don't have to go into the nitty-gritty of building the machine learning models, developing the algorithms, building the whole pipeline. All of this is fully managed by the specific service. There's just a couple of APIs that you need to leverage to build and deploy your models. And finally, one of the more interesting things, if you think about kind of the technological aspects of the service, is that it really does use state-of-the-art deep learning techniques. And these techniques are specifically tailored to take into account kind of the complexities that we mentioned before, right? So things like the cold start problem, things like the dynamic nature, the temporal nature of customer behavior. All of these complexities are basically what deep learning and do tackle in a state-of-the-art fashion, and that's what Personalize has embedded within their system. Now, how does Personalize work? Now, from a user perspective, it's pretty simple. Basically, you bring in the data, you upload the data to the system builds, trains, explores, finds the best solution or best model for you, and then allows you to deploy the model as a fully managed API. Now, what the system really requires from us, from a user, is the data sets, right? So what type of data sets are we expecting? The only required data set is what we call a user item interaction data set. So this is going to be the heart or the fuel of the system. Basically, we're going to provide our own personal, our own business data. And what Personalize expects is a data set that contains at least or at minimum 3 fields. So the first field is going to be our user ID. Second field is going to be our item ID. And third field is going to be a timestamp. So if you think about kind of a clickstream data or an event data, an event will be completely defined by these 3 variables. Now we can add more features, more variables, but at least at minimum, that's what Personalize is expecting. User ID, item ID, timestamp, and this represents a click or an event. Now what we can do is we can add additional variables to that data set, or we can bring in a couple of other data sets which are optional. So the first data set which is optional is the item metadata data set. Basically, you can provide specific static metadata about your item catalog. And then we have user metadata, which is exactly the same but for users, right? So this can be, for example, user demographics, age, location, etc. Now these 2 data sets are optional, and what they're there to do is basically if they have appropriate information, then they can always help enrich the models. Now, what does Amazon Personalize do when you provide this data? So Amazon Personalize under the hood is going to look at the data. It's going to identify which features are what, specifically because, as I mentioned before, we have these kind of reserved features that it uses in the models. So it's going to extract that information. It will do a little bit of data manipulation as well, data cleaning. Once you actually start looking for a model or start looking for a solution, Amazon Personalize will fine-tune the model, select the best, the right hyperparameters. It will train the model for you, and then it will give you kind of the best or the best performing model, so that then you can, by the use of an API, deploy that model and host it via different ways. You can either do batch transform, or you can deploy as a fully managed REST API to serve to your applications. Now, as you see, because most of kind of the whole pipeline or the mechanics that go into building, training the models, and deploying are mostly managed by Personalize. The key here is really about getting good quality, clean data in the right format. And once you have that, it's going to be really straightforward to build an engine and deploy it. Now, how does the ingestion process work? Now, the initial way to really interface with Personalize is by training your first model with what we call kind of batch data or offline data. So that's the data sets that I mentioned before in a CSV format, putting them in our location, in our storage service, and then feeding them directly to Personalize. Now, there's a second way of actually ingesting data, which is once you've deployed a recipe, you can actually ingest the data with a real-time event ingestion API. And this is something that you can hook directly to your client application. And this will stream the data directly into the system, which will allow you then to retrain the models or to train the models with that new data. Now, how does Personalize, kind of what are the internal modules that Personalize uses for this? Like I said before, it's mostly 3 different modules. We're going to have our data sets, we're going to have our solutions or our models, and we're going to have our deployed solutions or our deployed campaigns. When it comes to the data set, there's kind of a higher level abstraction for a data set or a holder object for the data sets, which is the data set group. This includes the interactions data set, which is the required data set, and the 2 optional data sets, which can be the items and the user metadata. Once we have our data, this data will be directly tied to or mapped to a set of solutions. Now, when we'll talk about solutions, it's really just the model that we're going to be building. And so you can build different solutions with different recipes. So we'll talk a little bit about the recipes and then kind of version those. And then finally, once you've built the solution, all you have to do is then deploy a campaign. And you can deploy in different fashions. One way to do this is do it through doing a batch transform or a batch job of inferences. This is good sometimes for saving money. But if you want to deploy and have a real-time endpoint to serve your requests in real time, then you can deploy what we call a real-time campaign. And now, what are the type of use cases that Personalize tries to solve? The first one, or the kind of the more canonical one, is what we call the personalized recommendations. So this is typically what people think about when they think about a recommendation engine. This is, if someone like this, if I click on something, then the system will give back, other users who like this also like these type of things, or this is the most relevant items for you. We have a second recipe which does strictly similar, most similar items, or what we call related items. If you want to add an additional logic, this is also very relevant. And finally, we have what we call personalized re-ranking. So this is one is particularly useful for when, for example, you have a search engine, you want to give back results based on the relevancy of the query, but you also want to weigh, or you want to rank those results based on customer behavior, right, or based on customer profile. So that's what personalized re-ranking does. You give us a list of results from a query, and what you can do is then re-rank them based on a user profile. Now, the underlying models that, like we said, that Personalize uses are deep learning models. One of the kind of core recipes that's being used, or algorithm that's being used, is called the hierarchical recurrent neural network, so HRNN. And just to give you an idea, this is state of the art in terms of what we call the kind of the public benchmarks for recommendation engines. So that's the Netflix and MovieLens data sets. HRNN does produce state of the art results. Now, how would you typically look at an architecture like this? Again, you have your client application, your customers browsing on this. Anytime you get a customer clicking on a specific item, or you do a request for recommendations, your server is going to send a request to a real-time endpoint. Personalize will then look for the results based on that information, and what we'll get is a set of recommendations. So we're going to get a list of recommendations that then what you can do is you can parse, or you can offer through widgets or through a push notification, however you want to present that information to your user directly in real time. So why don't we now jump into the console and see how we can actually start building a recommendation engine with Amazon Personalize. So let me walk you through the different steps necessary for building a recommendation engine with Personalize. Now, I'm going to start playing with a dummy data set, which includes, like I mentioned, the basically interaction data, which is the only required data set to get started with Personalize. As you'll see, as I mentioned before, we need 3 different fields to get started: a user ID, an item ID, and a timestamp. So for this particular use case, we'll be building a recommendation engine for a music application, which will recommend different artists to our users based on their historical interaction data. So as you can see here, we have a user ID, which is mapped to a number. We have a artist ID, again, codified as a number. Our artist ID in this case is going to be our item ID. And we have a timestamp. Now, typically what we would do in some pre-processing is we'll try to define or manipulate our data so that it fits the specific schema that Personalize expects, which is what we're doing here. We're mapping our user ID to user ID, our artist ID to item ID, and our timestamp to timestamp. Now, these are the variable names that Personalize expects. So once we have our data in the right format, what we'll do is we'll export this data to a CSV file, and we can start building our application. So today I'll walk you now. All of this, you can actually build everything programmatically through the AWS or Personalize SDK. Today we'll actually be building with the console. So you can actually go to Amazon.com or AWS, click on console and look for Personalize, and you'll arrive at a console that looks kind of like this. Now what I'd like you to do, what we can do is we can get started, and the console is kind of just a really nice way of starting to build through a nice UI or web UI our applications. Of course, like I said, everything you can do programmatically if you want a little bit more flexibility. We can start. So the first thing we're going to do is we're going to define our dataset group, as I mentioned before. Dataset group is basically going to be an abstraction that's going to hold our different datasets. In this case, for today, I'll only be using the interactions dataset. I'm going to give a name to my dataset. I'm just going to be uploading my interactions dataset. So let's do interactions demo. I'm going to use the existing schema. So schema is basically the way we're going to define the input fields from our dataset. Now we can, this is pretty flexible. It's basically just a JSON dictionary where we define the name of the field and the type of the field. Now, like I said, the minimum expected format is having the user ID, item ID, and timestamp. You can always be more flexible in terms of adding variables, like contextual variables, if that's what you want. For today, we're going to stick with this. So I'm just going to click next. Next thing is actually defining how we're going to import our data. So we're going to be pointing to our specific data set. Again, this is a CSV file which I've created, which I've pushed to our storage service S3. That's where Personalize expects the data to be. Again, it's a CSV file that we just saw before. I'm going to call this my interactions demo. No worries about this. We typically need a role Now this role I've already defined, don't worry too much about this. Roles are just a way for Amazon to, for AWS to define how you can have access to different services. So I'm just going to use this that I've created previously. And what we're going to do now is we're going to define the location for our data. Now, in particular, our data has been exported to, and we're going to look up where that location is. If you just give me a second, here it is. So our data is in a location that looks like this. So once we do that, basically what's happened is I'm asking the service, or I'm letting the service know that where it needs to look for the data to upload the data to the system. Because I created my CSV file located in a specific location in S3, our storage service. Now Personalize can go into that specific location, that directory, and extract the data and import it to the system. So it's going to prep the data. Like I said, we saw the little graph before where it's going to look at the data, find where the variables are, do some data manipulation, basically prep the data so that we can get started building our solutions. Now this takes a little time. So let's fast forward to when the data set's actually imported. Now this process takes around 10 minutes or so. Once we have the data set already active or imported, what we can do is we can start building a solution. So you can see here in the console, our data set is active now. We can actually take a look at the specific data set. We can look at details of that. But let's just go back to where we were. So we can go to the dashboard. What we can do now is we can start creating a solution. So you can see that in the console, the different modules that I mentioned are here: data set, import, solution creation, and then campaign launch. There's an additional field here, which is the event ingestion, which I mentioned previously. There's basically an API for ingesting real-time data. Now, this is a really interesting option for two things. First is that you have a way to stream data directly into the system. And second, that the models will be dynamically updated on real-time data. So it can be a really powerful tool to implement as well. But once we have the data ready, what we can do is we can start creating a solution. So from the console, I can click on Start. Let's say Solution Demo, let's call this. And what we do here is we have a set of recipes that we can select. So the traditional recipe, so as I mentioned here, we can do the related items. We can do personalized re-ranking, or we can do personalization. Now we have a baseline, most popular item recipe. This doesn't do anything else than give you back the most frequent items. We have the HRNN model, which is what I have mentioned before, and we have a new recipe called AWS User Personalization, which additionally provides kind of a way to do exploration. So this is a way of updating our model through real-time exploration. So real-time, being able to actually give users kind of novel items and see how they react, etc., etc. So it's a really powerful tool. For now, we won't be using this. We'll use kind of the legacy HRNN model. Now you'll see here you can actually use this out of the box, or what you can do, you can use hyperparameter tuning, or you can give your own set of parameters for the algorithm. Now for today, you can decide how you want to do the featureization or feature transformations, etc. Now for today, we'll just leave it at that. We're just going to use the default settings. I am just going to have this here, and I am going to click on Finish. Now what this is going to do is it's going to trigger Amazon Personalize to take our data, look at the model configurations that we've defined. Now this is all default configurations. It's going to look for the set of parameters for the model that optimize the accuracy of the model, and it will spin up necessary resources to actually train this model. So once we do this takes a little bit of time. We'll let this run. Again, we're just going to fast forward a little bit to when we actually have the results. So let's take a look at the solution, which should have been created already. As you can see on the dashboard, we have our data sets which have already been defined. We have a solution which has already been created. Now what we can do is we can click on View Solution. This is the solution demo that we had just defined. If we go to the specific solution, we'll see that the solution has been created, so the model has been trained. This is how long, not on clock hours, but on actual compute hours it took to train the model. All of it, of course, fully managed by AWS. And Personalize does give you some offline metrics as references to define, what is worth actually putting in production or not. Now the great thing about this is if we go back to the dashboard, now that we've created a solution, what we can do is actually deploy a campaign. So we don't have any campaigns available yet. What we're going to do is we're going to deploy a campaign, just call it campaign demo to be consistent. We can point directly to the solution or the model that we just created. We can actually define the minimum amount of provisioned TPS. This is just a way of so these endpoints will scale automatically. But if you have a specific amount of traffic that is coming in, or that you kind of can preview, this is just a good way of avoiding any kind of operational issues. If you have kind of an increased peak in traffic, etc. So let's go ahead and create the campaign. Again, this is going to take a couple of minutes. We'll do just as before. We'll fast forward to when the campaign has been created and deployed. Great, so the solution has now been created. Well, what we're going to do is we're going to look at the campaign, so you can see that the campaign that we just deployed is now active. That means that we now have a fully managed real-time endpoint that we can access that's going to be hosting our particular model. Now we click on this on the console, what you'll see is that you can actually test your deployed campaign with some user IDs. So for example, I remember when we had created looked at our data set, we saw that the first user in our data set had a user ID of 2. So what we're going to do is we're going to see if we can get some recommendations. As you can see, we get a set of recommendations. So these are the list of item IDs. In our case, those are the artist IDs with a set of scores. And of course, we're going to get this list in a descending order. Now, of course, a lot of the different configurations for what's being sent to the API and what's being what's being returned are mostly configurable through the APIs. Now, to see if this actually changes, if we change user ID, let's hope that user ID number 35 has a different is actually existing in the data set, and we can see that when we change the user ID, we get a different set of recommendations with their own scores. Now, as we saw, basically with a couple of APIs of a couple of clicks, we were able to set up a fully managed real-time recommendation engine that now we can actually implement within our application. All we needed to do was define our data set, import the data set into our service, deploy a campaign. Create a solution, and then we were able to deploy a campaign, which now gives us kind of a reactive set of recommendations based on the specific user that we are providing. Now, if we want to see how that actually looks like in a real use case, so let me just show you a demo application that we've built. So we've built this, basically it's a dummy e-commerce or retail website that is fully built on AWS services, of course, but the underlying infrastructure, the underlying logic is built on Personalize. So for example, we have a set of different personas or different users. You can see how this is going to change the objects or the items that are being offered. So if we go from Olivia Achiever to Joe Average, for example, we see that the landing page or the products that are being offered is different. Now, if we click on a specific item, we'll see that we have two different options. The first option, and this takes a little while to join, is we're using the Sims recipe to get the similar items. And we can also use the Personalized HRNN recipe to get recommended items as well. Now, if you want to see how the personalized re-ranking object works, for example, if we look at cereal and we do a search, typically what we get in the back end, it's using Elasticsearch to return a set of most relevant items from our catalog. And what we're doing is we're using Amazon Personalize to actually re-rank those items and give us back a set of results. Okay? And of course, if we change the user or the user profile, this will also vary based on that user. The main message that I wanted to get across was how easy it can be to bring your own data set and with a couple of clicks build and deploy kind of deep learning based recommendation engines to complement or to enhance your customer's user experience. So I'll give it back to Bernard for closing statement.
Thank you, Pedro. If you're interested in learning more, visit aws.training/machine learning to explore the learning paths, including digital training and instructor-led classes. You can also validate your skills with AWS certification. We hope you found this session on Personalize helpful. If you would like to learn more about AI and machine learning, visit our resource hub to get access to the newly created resources that will help you to learn more about AI and machine learning. This brings me to the end of the session on Personalize. If you are interested to learn more about what I've discussed today, you have several options available to you. Thank you for attending our session. I hope you enjoyed it. And please remember to complete the survey. Let us know what you think and how we can improve the event experience for you.